Jenny, and in today's video we are going to create the experiment 7, which we will design and implement a VLSM addressing scheme. So this is the topology we will consider in creating this experiment. So for the objectives, we can see examine the network requirements, design the VLSM address scheme, and cable and configure the IPv4 network. So for the instructions, let's go to part 1, which is determine how many host addresses and subnets are available. So for this one, how many host addresses available in a /25 network? So as we can see, there are 126 usable hosts. So y it is raised to 7 equals 128. So if we count the bits, if we convert it into a binary, which is the subnet of a /25 network is 255.255.255.128. So this means that it is composed of all ones, 8 ones on 255, 8 ones on 255, and 8 ones on 255, which can be total to 24 ones, and additional borrowed bit, which is 128. So this will look like this. Let's open our notepad. So this is the first 255, first 25 second. So this is 24. So 1, 2, 3, 4, 5, 6, 7, 8. So 8, 16, 24, and the borrowed bit will become 25. So the remaining are the zeros. There. So if we count the zeros, 1, 2, 3, 4, 5, 6, 7. So it composes of 7 zeros. That's why it is 2 raised to 7 to determine the host addresses. This zeros represents the host in binary. So let's delete this one. So since it 2 raised to 7 is 128. However, the two IP addresses are reserved for the network address and the broadcast address. So by subtracting it to 2, we come up a 126 usable hosts. Based on the topology, we have 80 host addresses needed. So 40 plus 2 plus 25 plus 5 plus 4 is equal to 80 hosts. And considering how many subnets are needed, based on the topology, 1, 2, 3, 4, 5, 6. 6 subnets are needed. So let's determine the largest subnet. For this one, we can say it is the BR1 LAN since it requires it should be supporting 40 hosts, so this is considered as the largest subnet in the network. Which subnet mask can support that many host addresses? For this one is 255.255.255.192 or a prefix length of /26. Considering how many total host addresses can a subnet mask support, the same procedure with this /25 computation, 2 raised to 6 since we borrow another 1 bit. So it will become 64. The 6 represents the zeros earlier like here. So for a /26 prefix length, it should be like this. So counting all the zeros, 1, 2, 3, 4, 5, 6. So this is the available number of hosts for a /26 network. So we have 64, and as we know that, or as I said earlier, that the two IP addresses are reserved for the network and the broadcast address. So we should subtract 2. So it will have 62 usable hosts. So can we subnet this to our original network? Yes, since /25 is larger than the /26 network. What are the network addresses that would result from this subnetting? This is the first network address, which is the 192.168.33.128 up to 191/26. So use the first network address for this subnet, which is this indicated here, which is the 128 for our network address. So the second largest is the BR2 LAN. So we will subnet the second network address from the /26. So how many IP addresses are required? As said in the topology is 25. What subnet mask can support that many host addresses? The subnet mask is 255.255.255.224, or the /27 prefix length. How many total host addresses can the subnet mask support? Same calculations as earlier. 2 raised to 5 is equals to 32, and 32 minus 2 is equals to 30 usable hosts. Can you subnet the remaining subnet again? Yes, since the /26 can support more hosts than the /27, so we can subnet the remaining /26 network into /27 prefix length. For the network address of this subnet is 192.168.33.192.223.223/27. So this is the first network address, or the first network address for this subnet. So we will use this one for the second largest. Let's determine the third largest subnet, which is the BR2 IoT LAN. It requires 5 IP addresses, which can we subnet it into 255.255.255.248 or /29 prefix length. So if we compute it again, let's try. So this is the /26, /27, /28, 24, 25, 26, 27, 28, and 29. So we can see 2 raised as 3 zeros. So 2 raised to 3 is 8. So 8 minus 2 is equals to 6. 3 raised to 8. And 8 minus 2 is equals to 6 usable hosts, because the two IP addresses are reserved for the network and the broadcast address. So can we subnet it? Yes, since it is larger than the slash 27 network. Since slash 27 network is larger than slash 29 network. So what would the network addresses that would result from this subnetting? This is the first one, 192.168.33.224 up to 231. So for the second one, it should be, let's put a separator here, slash 23232 up to 239 slash 29, and the last one is 1 192.168.33 slash 240 up to 247 for the last, for the subnet. This is the third subnet. And lastly, for our last subnet, it's 248 up to 255. 254 subnet mask. I saw IP address. So we can see it composes of four network address. So the first four subnet networks. So the first subnet is reserved for the IoT LAN. The CCTV LAN is for reserved for the second, and the third is reserved for the HVAC C2 LAN. So let's determine the fourth largest subnet, probably the last one, which is the BR1 BR2 link, and it requires two IP addresses, and the subnet mask is 255, the 255, the 255.252, or the slash 30 prefix length. So this is what it looks like. So this is 29. So this is 30. So this is, since there are two zeros, so 2 raised to 2 is equals to 4. Since the two addresses are reserved for the network and broadcast, there are only two usable hosts, and we can subnet it, and this is the resulting network addresses, which is 192.168.33.248 slash 251 slash 30. Proceeding to our table. So this is uh, the complete information after we compute and subnet the network. So as we can see, there are slash 26 prefix link, one slash 27 prefix link, or the CIDR, two or 3 slash 29, and lastly there are one that is in slash 30, which reserved for the link of the two routers, or the BR1 BR2 link. So this is the interface that we are going to need, and now we will proceeding to the cabling of our network. Here in the Cisco Packet Tracer environment, and we will start the cabling process. So looking back to our topology, we have two switches and two routers. So let's use the 4221 router and the 2960 switch. So let's go. Here are the 2960 switches and the routers. So let's use this 4331 in replacement of the 4221. So this will become BR1 LAN. Let's rename this switches. And this is the BR2 LAN. And the BR1 and BR2 respectively. There. So this is the routers and switches needed. So we will cable this now using the copper straight through. And based on the topology, fast Ethernet port 05 is connected to Gigabit Ethernet 001 on the router 1, connecting it using the copper straight through. So this is the fast Ethernet connected to 001. And the same process connected to from switch 2 to router 2. So fast Ethernet 5 connected to Gigabit Ethernet 001. And to connect those routers, we use this Gigabit Ethernet 0/0/0 and connect it to the other Gigabit Ethernet of the router 2. So now the switches and the routers are connected. So we will try to configure this router and switches. For this one, we need a PC to configure those ports. We can configure these routers and switches through their CLI, but in real life, we will use a PC and we will connect it through the console port. So let's try to configure the router. We will use the PC0 and connect it to BR1, which is console. There you go. And click the PC0 and go to the terminal and click OK. Select no for this one. So we can now configure our router. First requirements is assign device name to the routers, assign class as the privilege executive encrypted password for both routers, Cisco for console login, and Cisco for VTY password login, and encrypt all the plain text password to the routers and create a banner message that unauthorized access is prohibited on both routers. So let's configure with these instructions above. So with our console, let's enable the privilege executive mode, then configure terminal. So first, let's change the host name of our router. to BR1. So now the name is changed. So let's set the passwords required. For the console, just type line con 0 or line console 0 and then type password. For our password, we should set it to Cisco. So let's say password Cisco, then log in, then exit. Now for the VTY lines, it's the same. Line VTY, but this time 0 space 15. And we will type password Cisco since it is stated that we should set the password to Cisco, then log in, then exit. Now we will use this class privilege accept encrypted password by typing it to enable secret and the password which is class, so we will type class. So now we enabled encrypted privilege accept password. Let's encrypt all the plain text passwords, which are, we will type service password encryption. So now all the passwords are encrypted. Let's set our, one of the requirements is create banner that will warn anyone. So we will uh, create a banner message of the day. That's why it's called banner MOTD, and we will type the message. This is the message. Unauthorized access is prohibited. There. So this is the banner message. Click enter to set it. So now everything is set for router 1. Let's try to assign an IP address and subnet mask to each interface using the table that you completed in part 2. And let's configure an interface description and activate the interfaces. Okay. So this is the table from step 1. So here is the calculated and this is the completed on the step 2. So we will use this one to assign those configurations for the router. So let's proceed with this interface 0/0/0 or the device interface for BR1 BR2 link. Okay, let's go. So we will type interface gigabit Ethernet 0/0/0. And now we are in the interface of gigabit Ethernet port 0. So we will type IP address and the assigned address for that, which is 192.168.33.249. So we will assign this one address 192.168.33.249. And since it is a slash 30T prefix link, so the subnet mask should be 255.255.255.252. Then press enter, and then no shut or no shutdown to manually up. And now it changes to state to up, so we can exit this interface. So next is the interface of gigabit ethernet 0 port 1. So interface gigabit ethernet 0/0/1. The same one. Oh, we have a problem there. Oh, we forgot the description here in the router. So let's try to edit that. Interface gigabit ethernet 0/0/0. Then we will add the description. So description, and this description, which are the BR1, BR2 link, and then exit. So we can interface the gigabit ethernet port 1, or the one that is connected to the switch. So interface gigabit ethernet 0/0/1. So now let's add the description first, so we cannot forget but the adding description. So this is description for the host LAN. So let's set the IP address. For this one, we will use the first network, which is here 192.168.33.129. So this is 192.168.33.129, and the subnet mask is from the /27, which is 255.255.255.192. Then enter, and we will turn it on by typing no shutdown or no shut. And now it is manually up, or the state is changed to up. So now we can exit, and now we are already activate the interfaces for the router 1. So we can save the configuration by going back to the privilege executive mode, and then typing copy run start, or copy running config start config, then press enter, then press enter again, and now the configuration is saved. So we can exit this one. So exit. So we will type Cisco, and now we are going back to the user exec mode. So we will close this one, and now we can safely say that we can disconnect this one. So let's disconnect the console port here. And now we will connect it to the another router, which is the BR2. Same procedure that we did on the router 1. So now let's configure uh, the router 2. And now we are back to the user executive mode. Let's try to ping the IP address of BR1. Let's try. So we can ping here using the terminal from the router. So we can see it's successful. The ping is successful. So let's try to the other router. Let's disconnect this one. Cancel. Let's disconnect this one and connect it to our BR1 link. So let's try to uh, ping this one. So ping. And we can see the ping is successful. So we can say that the uh, connectivity is successful and we configured the routers correctly. And we also subnetted the network of and we successfully subnetted the network, which is here 192.168.33.128/25 network. Hope you like this video and see you again next time.